All right, so we're going to pick up where we left off in regards to water cycle from yesterday. But before we do that, you all have a piece of scrap paper in front of you. In that scrap paper, we're going to create 4 squares. And we're going to talk about some things in doing that. So on your scrap paper, what I want you to do is either fold it or draw 2 lines, creating 4 squares. You don't need to come up here. You'll be able to see just fine. Where's your glasses? I forgot my glasses up there. If you need to sit right there, that's fine. All right. In the 4 boxes, I am going to write the instructions for what you're going to do. You are not going to write the instructions. You are going to follow the instructions. Are you going to write the instructions? No. No. Just follow them. All right. So for square 1, which is this one here, that. You're going to write hold on, let me make my pen a little smaller. Do you or anyone you know collect things? No, I don't want to hear your answers. I just want you to write your answer in there. Box 2, you're going to write, what do you or someone else collect? Now, you guys have to kind of think outside of the box. You might not know them personally, but you might have seen somebody on TV, on a show, on a fictional show, on a non-fictional show. So think of those things. Box 3. No, don't talk, Patrick. Why do you or this should not be there. Or the other person collect things? And then lastly, box 4, what will happen to the collection in the future? Let's take about 3 minutes to complete those boxes. Now, you may whisper among your group in case you're struggling on thinking of somebody that collects, or maybe you collect something but you don't realize it's a collection. You may whisper to your group. What's up, Eddie? No, then you have to talk within your group because you can figure out somebody that collects something. You watch television.
So for the first one, we don't put what they collect, we just put the person name.
Either the person name or yes, you know someone, or yes, it's you. One more minute. Oh, now, I don't know. Okay, my turn. My turn. Raise your hand if you or you know someone that collects something. Everyone's hand should be up because you all watch television shows where somebody has affiliated with some type of collection. If you know any superstars, you better get your hands up because they're famous for collecting things, cars, houses, money. All right, hands down. What do you or that some person collect? Raise your hand. Chris.
I collect rocks and gems.
Okay. She said rocks and gems. Simon. Okay, so you know someone that collects rocks, but you collect sports cards. Money and seashells. Okay, Patrick.
Basketball memorabilia.
Okay. Hands down. Why do you or the other person collect things?
You never know when it's going to be valuable.
You never know when it's going to be valuable. Very good. Jamil. I just want to know number 3. You want to look back at memories, okay?
So when you have the item for a long time, it'll give more value.
Okay, you collect it for value.
It means something to
It means something to you. Okay, hands down. Number 4. What will happen to the collection in the future, Jenny?
You can sell it.
You can sell it so you can make a profit. All right. No? Dorian?
It will continue to grow.
What do you mean? Like in profit or the size of the collection? Okay, so your collection will grow. Good. Jamil? No. But what will happen?
I'll keep it like.
But what happens to it? You're keeping it safe. What happens to it? It's preserved?
Yeah.
Okay. Duran?
Or we make a big pile up behind with other.
So you want to grow, your collection to grow. Okay, hands down. Now, we're going to tie this in just a moment to the water cycle. So, that was just scrap. You can just put that to the side. We'll toss that out. But I want to take a look at a video about the water cycle. And while we're watching the video, I want you to think about how that relates to collection. Okay? Think about how the water cycle relates to collection. No, I want you to watch the video and think.
Water is as old as the earth. As far as we know, the amount of water on Earth has never changed. That's amazing when you think that the water in your faucet may have been deep in the sea millions of years ago. Or it may have been in a glacier for 1,000 years. When you are done with it, it goes down the drain, and sooner or later back to a lake or ocean, where it may rise up into the sky and form a cloud that travels around the world to be used again. All over the planet, the sun helps nature recycle water in the water cycle. The water cycle has 3 main parts. Evaporation is when water turns into invisible water vapor and rises into the air. Condensation is when water vapor forms clouds, dew, or frost. And precipitation is when water falls from clouds as rain, snow, sleet, or hail. There is also a 4th part to the water cycle. It's called runoff, and that's when water runs downhill to flow into streams, lakes, or oceans. In the water cycle, we see water's different forms and properties. It can be solid ice that does not change shape, liquid water that moves and flows, or water vapor that floats in the air. The parts of the water cycle can control the climate of cities worldwide. Some places stay warm and wet, while others stay cold and dry. The water cycle is like an engine, and the fuel for it is heat from the sun. The more heat that comes from the sun, the faster the water cycle works. At night, and even in places where you don't have much heat, the water cycle continues as liquid water changes to ice or water vapor and back again. We call these phase changes. The water cycle makes sure that clean water falls from the sky and is spread around the earth in one way or another. This makes it possible for people, plants, insects, and animals to survive and live almost anywhere.
All right, so let's think for a moment. What does collection mean? What does collection mean, Duran?
Building up.
Okay, collection means maybe the building up of something. To gather. I like that. Let's think about that. What does it mean to gather? Oh, Jenny.
Are you talking about your life cycle?
Just period. What does it mean to gather? To get things together. Now, knowing that collection means to build up, to gather, to get things together, what does that have to do with the water cycle? Rajala. It does gather in the ocean to prepare it for what? Evaporation, which then prepares it for what? Condensation, which then prepares it for what? Precipitation, which then prepares it for what? And collection, groundwater. All of that is reused. It's collected. The earth is saying, give me my water back. Basically, when you get your things back, you're collecting your things. So the earth is collecting its water, one second, Patrick, and it's getting it back because we don't have any other water. We don't go to your hometown on Mars and say, let me use your water. That water goes in a continuous cycle, a continuous movement, continuously. There is no new water. The water that you use today is the same water that's been used thousands or millions of years ago. And it continues, and it continues, and it goes over and over and over again.
Well, you know how California has like a drought right now? If like a flood happens, is that going to help them?
Of course. Yes. It'll hurt, but it'll also help. Yes.
How come when you say like 2% of our water we can actually
1%.
Oh,
That's actually fresh water that we actually use. We still have water in the ocean and stuff like that. That's the water that we don't necessarily use. We don't wash with, we don't drink, we don't brush our teeth with, we don't cook with, those types of things.
Is that 1% regenerated?
Yes, it has to.
Okay.
Yes. Ooh, we will check that later on in our units. Good question. You'll figure that out yourself. Patrick.
You said that water doesn't grow or
It doesn't. It doesn't grow and it doesn't deplete. We continuously use that 1% of water, and then the rest of the water is continuously used from the oceans and lakes and things of that nature.
like that dog that was in there, like, can you still one?
Keep going. I see where you're going, but keep going.
And you get it up with like a box. That water's still in that box.
But what happens when it heats up with that water? It evaporates. And it goes into the air as gas, which helps form our clouds, which then precipitate. It doesn't happen where that water comes back to us tomorrow, but in 100 years, in 1,000 years, a million years, that water comes back. We have no new water. Yes, good question. Go ahead, Ray. What happens when you drink water?
Oh, eat it out.
You pee it out. Where does it go? Wait. Shh. Where does it go? Down the drain with the other water. What happens to that water? Sewage. Then what happens to that water? Filters out to the lake, and then what happens to that water? Evaporates. Now, maybe you don't pee out all of your water, but what happens through your skin? You sweat. That's water. What happens when you breathe? You breathe out water vapor. My turn. Pee is acidic, but it is made of water. Anything that's liquid has water in it. Yes, we talked about that. All of that is going about.
So at night, what
That's leading on to my next question. Very good. Thank you very much. So, what is the power of the water cycle? The sun is the power of the water cycle. It makes all of this happen. Now, the sun is known for its what? Heat. So, when it is sunny out and there's heat, what process of the water cycle is occurring? Like what phase change is happening or phase changes are happening? Eddie? A solid to a liquid or a liquid to gas, right? And that is solid to a liquid is doing what? Solid to a liquid. Melting. Or a liquid to a gas is evaporation. Now here's where you come in with your question. The absence of the sun. When the sun is absent, what's happening? What's the temperature then? It's cooling down. So it's still powering the water cycle because it's not there. It gives the fuel to heat things up, and it also takes away the fuel to cool things down, which means that the phase change would be what? Phase changes would be what? Phase change. Phase change. Gas to a liquid, which is condensation, or liquid to a solid. It's cooling down, which will be freezing. And you could precipitate with like that with your snowflakes or things of that nature. So the sun still powers it because if the sun's there, it's going to do heat up. If the sun's not there, it's going to cool down. Patrick.
I thought that the sun always heat up.
It does always heat up, but if it's not there, then things are going to cool down.
But it's always, it might not be in like.
It always sunny? That's what you're about to say? Because it's not.
It's like, it might not be in North Carolina, but it's still out there.
Then out there, so wherever the sun is beaming in that area, then it's heating that area up. And wherever it's not beaming, that area is being cooled down.
But isn't it the wide walls that have like blue coming through?
Yes, that's condensing too. Yep, on the grass. Last question, then we're going to move. That does hurt. That does help also. Okay, so now let's move on. You have in front of you your sheet that looks like this. It says Groundwater Vocabulary. You don't have to see this per se because I'm not going to keep this sheet up here and I'm not going to write on this sheet. I just want to make sure that you have this sheet in front of you. This is page 7 of your notes. On this side, you notice it has Groundwater Vocabulary. You flip over, that has Groundwater Notes. We're going to be working on this side that says Groundwater Vocabulary. We're going to go through a presentation of slides which you will be able to synthesize the definition. That means come up with the definition. I provided definitions on your paper, but I did not provide the words. You have to fill in the words. On the slides, I will show the words. We will see the picture. We will talk it out, and you will figure out what definition belongs to that word so that you can fill it in. Any questions on what we're doing? Okay, then let's go to the first slide and take a look. The word here is infiltration. Does everyone see that?
Yeah.
Okay. For infiltration, if we look at our paper here, we will see infiltration is right here. Now, before we talk about water or anything like that, let's look at that word infiltration. What does that come from? The word what? Infiltrate. Now, think about it and then raise your hand. Don't yell out. Where have you heard the word infiltrate before? In what type of scenario have you heard that word, Duran?
In like maybe a movie or a game when the soldier or whatever trying to get into an area.
Okay, in a movie or a game where a soldier's trying to get into an area. Now we got to be a little bit more specific. Is a soldier trying to get into a party where he's welcome, or is a soldier trying to get somewhere where he's not welcome? Not welcome. Which means that if you're going to a party, you won't need to sneak in to the party because you're welcome. You've been if you're invited to a party, I should say. If you are invited and you have been given permission to go to that party, you don't have to sneak in. You are welcome, correct? If you are uninvited to something, you are breaking in, correct? So therefore, infiltration must mean something about breaking in. Now, because we're talking about water, what are we talking about? Water. Water doing what? breaking into something, right? So thinking about infiltration meaning to break in, water is breaking in. What definition do you think goes with water breaking into something? And read it right off of your paper. Let's see if you got it. Chris. Process that water enters the ground. Well, let's check and see. This is the process that water enters the ground. And the picture shows that water is breaking back into the ground. In addition to writing your vocabulary word, underneath the definition or next to the definition of infiltration, I want you to write process of the water cycle or part of the water cycle because we build onto it. This is also a part of the water cycle. When water runs off, it hits the ground surface. When it hits the ground surface, it must seep through or break through the ground. That breaking through the ground is called infiltration. So make sure you put next to it, this is part of the water cycle. So step up. Any questions? Can I move? Okay. Here, we're going to look at, first, transpiration. Just as a review, looking at your definitions, raise your hand and tell me which one is transpiration. And this definition will not pop on the screen because this is review. Bryson. You got it? You got it? Devin, help him out.
Process where water vapor escapes from living plants.
Yep, process where water vapors escape from living plants and enter the atmosphere. This is transpiration's own what? Evaporation. What does what say? What? We're only right now looking at the green square. Okay? Everyone good? All right, so transpiration, we should have that. The next word is circled in red. It's percolation. It's one of your vocabulary. If you don't know how to spell it, then you need to go to your learning map and look at your vocabulary words because it is on there. Now, for percolation, how many of you heard that song, It's Time for the Percolator? It's time for the percolator. All right, what is he saying? What does he mean? What have you ever seen the video? Or someone dance to the song? Or what are you doing? You are moving. To percolate means to move. That's all that it means. So everyone right now percolate. Everyone percolate. Come on. I don't see you percolating. Let's go. Percolate. Percolate. Get it. Dorian, percolate. Got to do some moving. Move your leg or something. Come on. All right. All right, sit down. Sit down. So, if we look at this picture, notice where infiltration is in relation to where percolation is. And percolation means to move. Look at the picture and look at percolation in relation to everything else. And then raise your hand and tell me which definition is percolation. Chris? Nope. Go ahead, Jenny. Exactly. Percolation is ground surface where downward water becomes part of an aquifer. And you can put in parentheses movement and also put part of the water cycle. Movement, and it's part of the water cycle because once it precipitates, it hits the ground, it has to break into the ground, which again is what? It has to break. Infiltration. Once it infiltrates, it then must percolate. It has to move through the ground. It has to get through those spaces. Just like an enemy that's infiltrating. He can break in, but he also has to move about to get through. So the water has to be slick and move about. Don't forget to put next to that definition that it is part of the water cycle. That's another step up. Because that's part of that whole process of getting that water all the way around Earth. Any questions? Okay. This one we are looking at water table. Now, this should be a simple one to kind of break down because the table is the what? Is it the, what'd you say? It's a surface.
Wet surface.
And so this must be the surface of water. So it's the top surface of water. This blue stuff down here is water. The light, the yellow stuff is area that doesn't have a lot of water. And then obviously above where the tree and the cloud and the rain is, that is the earth layer where the earth is located. So looking at your definitions, what is water table, Simon? The upper surface of groundwater. That's the water table. I want you to add the part where it says boundary separating the zone of aeration and the zone of saturation. I want you to add that, those words. I'll give you a moment. And you should have enough space. You just have to write a little bit smaller. And the picture shows us that. Water table separates zone of aeration and it separates the zone of saturation, but it is the top layer of that groundwater. And the water table could move depending on, like Jenny said, in California, they're having a drought. So our water table would be higher or lower?
Lower.
Lower. If they had a flood and it was oversaturated, then that water table would be where? It would be higher. And sometimes water tables get to the level of earth where we get lakes. That's how lakes are formed.
Oh.
A lack of rain. Sometimes it is continuous, but it's continuous meaning that come out our pores, come out of the trees, but there doesn't always have to be rain to make the water cycle happen. Yes,
What is aerial?
we don't have aerial.
It's an area.
Aeration. We'll be talking about that. It's aeration. A-E-R. Has the word air. We're going to talk about that a little bit later.
Is the root word aerial?
No, the root word is air.
How do you spell air?
A-E-R.
Oh.
It's because aerate is the root word. It comes from Latin word.
Okay.
All right. Any questions? Can I move? Okay. All righty. Our next one is aquifer. Now, let's stop for a minute. What word do we have in aquifer? Aqua. And then fer, it's like in the word transfer. To transfer something means that it is being able to move. It's going somewhere. It's moving from here to there, right? And so transferring of what? Water. So it's moving from here to there. Look at your picture, first of all, because our aquifer is located all in this area, which is all under what? Under the ground. So it's our area where our groundwater is. Excuse me. So therefore, what would be the definition for aquifer? Aaliyah. Water located within the rocks below. Say it again. Below Earth's surface. That is kind of true. But let's hit that definition for just 1 second. Put your hands down. Water located within the rocks below Earth's surface. Actually, the overall term for that is what? The water that's below the ground is what? Groundwater. So fill that definition in for your first one, groundwater. Now your groundwater are your aquifers. Okay, if we go back to this area here, we notice all of this is groundwater. This is your water below Earth's surface, correct? So therefore, your groundwater it provides our aquifers. This is where our wells, if we look right here, where our wells are tapped into, our sewer wells are tapped into so we can get water that comes out of our faucet. We have to have an aquifer available to be able to do that. But the actual definition of an aquifer, Rajalyn, is? Yes, it allows the flow of groundwater. Everyone good? Aquifer, it's right there. Aquifer. Don't forget your glasses again. Like forgetting your brain, you need it. Any question? Yes.
Since you said that the water is underground, how come some of the trees have this bed?
Maybe that they're not in the area where the water is saturated. The water table could have dropped.
Oh, okay.
Any other questions? The good questions you guys are asking. Okay, then let's move on. Here we have aquitard. Now, you guys laughed and giggled because last time you thought I was saying aquaturd. I'm saying aquitard. Aqua means what again? Water. We're going to be adding this to our tree on tomorrow. So your do now will probably say add aquitard to your tree. So you have aqua means water. Now, take yourself to your immaturity for just a moment and think about, what word do you think about when you hear tard?
Retard.
You do think of retard, and I will admit that. But let's take that to a level of maturity for a moment. What does it mean? What does retard mean? It does not mean mentally ill. It doesn't. That's the misassociation that we associate with it, but it does not mean that. Rogerlyn, you know? No, don't give me the definition. I just want to know what you mean when you say retard. Nope. Let's take it one step further. If you come to school late, you are considered You're not considered a retard. You are considered tardy. So it also comes from the word tardy, which means late. Okay? So doesn't mean, it actually doesn't really mean late. When you are late, are you on time, fast coming, or slow coming?
Slow coming.
So therefore, tard means slow or stop. So this is water being what? Slowed down or stopped. Now look at your definitions and tell me which one is aquitard. Patrick.
First claim that do not permit the flow of water.
Do not permit or does not permit freely the flow of water. So this answers Jenny's question when she says, how come we have some trees that are dying? Those trees may be planted above an aquitard, where you're not getting much water because it's not an aquifer there to provide water. Also, when your parents may be planting some plants in their grass, they want to make sure they use the right soil and things of that nature. They want soil that's going to allow the flow of water. If you use clay is not a strong aquifer. Clay is a strong aquitard. It may not let that water flow. This is why some people place rocks in their yard to stop weeds and stop plants, because that's an aquitard. The water can't get through there, so things aren't going to grow. Yep. Any questions? Okay, we good? All right, moving on. Let's take just a moment of a break, but it also is a learning break, to see what we get out of this.
Are y'all ready?
Let me see.
I can't hear you.
All right. What is SpongeBob? Okay, so now let's see what the learning was from this. He says, oh, he lives in a pineapple under the sea.
SpongeBob SquarePants.
Here we go. Absorbent and yellow. What is absorbent? Soak up. It said absorbent and yellow and porous is he. He has little holes, which are pores. Now, it is important that a sponge is porous because it wants what? Water. It wants to allow space for water. Pores are holes, Holes. All right, pay attention. Pores are holes, which are spaces in between things that allow other things to get through, right? The maker of SpongeBob SquarePants is a marine biologist, so he made the show SpongeBob SquarePants because he loves marine biology, but he also threw in some things that are absolutely totally wrong. Listen, those mishaps are just silly. You catch on to those. Quiet for a second. The other mishaps that he makes are for his own humor because he knows that it's not true. For instance, a sponge cannot live at the bottom of the ocean. It won't survive. It has to live in the intertidal zone, which is the top portion of the water. Cracks. Sponges are cracks. We're not talking about that, and that's the other funny thing. We're not talking about this type of sponge that we wash with. We're actually talking about there is a sponge that's an ocean creature. We are also, in addition to that, Mr. Krabs is a crab. He also cannot live at the bottom of the ocean because he won't survive. A lot of things down there won't survive. We'll talk about that later too, and we'll come up with that. Put your hands down. I'm done talking about SpongeBob for a second. But going back to absorbent and yellow and porous is he. Pores are spaces that allow things to pass through. Hence the word porosity. Porosity must be what? The amount of space. Holes. Don't you when I ask you something for a definition, you cannot use part of the word that I'm asking you for. So when we look at the picture to the left as opposed to the picture to the right, we are looking at the red lines in between the yellow things. Those yellow things are rocks. Looking at the picture to the left in relation to the picture to the right, the red lines are spaces in between those yellow rocks. Which one has more space available for things to get through it?
Right.
The right. So which one would be more porous?
Right.
No. You're not answering my question. You're not listening. Which one would be more porous? The one to the left or the one to the right? The one to the right. So what does porosity mean? Don't you dare yell out. Jamil. You gotta speak louder. This percentage of open space between rocks or in rock spaces. Because you could have a bunch of rocks that allow a lot of space, or you could have an actual rock that is porous and allow things to go through, which is what a sponge is really like, a rock. All right. That's porosity. Now, next to it, we have permeability. To be permeable, notice it has the word ability, so this must be the ability of something, correct? Ability to be permeable. But what's permeable? To permeate something, what does that mean? Look at your definitions and see if you can figure that out. It obviously has something to do with porosity. So what would it be, Kwan? The ability to let the water pass. You'll notice on your definition, on your space, I have a TY. Accidentally, when I was blocking it out, forgot to take off the TY. So just add to that or cross off the TY and write the whole word permeability. So it's the ability to let water pass through. If something is highly permeable or has a high permeability, its porosity will be high or low. Listen to my question again. If something has a high permeability, will its porosity be high or low? High. The ability to let water pass through will give it more space, which means it's more porous. If something had a low permeability, will it have a high or low porosity? Low. Are aquatards permeable or non-permeable? Non-permeable because it does not have the ability to let water pass, which means that it's not very porous. Very good. Awesome. All right, moving on. Here we have a recharge zone. Now, what does it mean to recharge something? What does it mean to recharge, Ray? To re-energize. To re-energize can mean anything. It could mean whatever it needs to keep going. Like when you recharge your phone, you're giving it more battery life so that you can use it. What are we talking about here? The big what? Water cycle. To give the water cycle what it needs to keep going, we need to give it water. So recharge zone has something to do with giving water back to the earth. So which part do you think is the what definition do you think is the recharge zone? I don't know if did you guys fill all your definitions out? Okay, because I was about to say, I don't think I put the recharge zone on your definitions, but this is the ground surface where downward water becomes a part of an aquifer. So that I did put that on there, but we marked it as percolation. I want to fix that and put that somewhere else. That's what I was doing. For the definition, when you put percolation, put underground surface. Put underground surface. For your definition, where you put percolation. So just add underground and keep the rest there. And then underneath your definition for percolation, I want you to write this. Recharge zone is the ground surface where downward water becomes part of an aquifer. So again, I'll say it again. For your definition where we wrote percolation, we wrote ground surface is where water, put underground surface. And then we also put movement. Okay, I'm not moving, I'm just about to talk. Now, underneath, you have a question here that says, what process in the hydrologic cycle occurs in the recharge zone? Now, remember, we had some parts of the water cycle that we already knew, and we just added some more parts of the water cycle to it to advance our knowledge of what the water cycle is. So take about 20 seconds to think, then tell me what process of the hydrologic cycle occurs in the recharge zone. 20 seconds to think. And that question is also on your paper. It says think, time to think. 20 seconds. Just thinking. All right, raise your hand if you think you know. Aaron. Precipitation? No. Precipitation is still falling in the sky. Bryson? No. Aaliyah? Absolutely not. Let's stop for a second. Recharge zone happens at the ground surface where downward water becomes part of an aquifer. We have to think a step further, Jayla. Percolation and infiltration. Infiltration, then percolation. The water is now being recollected back to earth. It's the ground surface. It's getting back in there. That's where the earth is being recharged. Any questions so far? No, I said keep the word percolation there and add the word underground to that definition and then rewrite this for recharge zone. All right. On your paper, you now have this at the bottom. This is like a study guide because what happens is below this you have numbers 1 through 10. Do not fill in these blanks. Do not fill in these blanks. Where do you think you're going to put the answers?
On the bottom.
On the bottom. So when you are studying, you can fold the bottom back so that you don't see it. And you can start pointing out and labeling or saying what everything is. And then you can check your work. So this is your nice little study guide. So right now, I want you to take about 5 minutes by yourself and use a pencil in case you have to erase. And at the bottom of the picture, start filling out 1 through 10 what the picture is representing for those numbers. Go now. Everyone should be working and thinking. Let's look at your own paper so that you're checking your own knowledge. This is not a test that you'll be graded on, but it's a test of what you just retained. Using your definitions as well for a moment. My picture looks just like yours. Oh, I know yours may be a little bit darker. Yes. Number 7 is pointing to 2 arrows. They're doing the same thing. Yes. Number 3 is pointing to that top portion of the ground. About 2 more minutes. Jamil, you don't look like you're writing. Don't wait for us. One more minute. Well, there are, just so you know, there are 2 areas on here one area on here that you do not have a vocabulary word for, so this just comes from your knowledge of what you've just seen in our presentation. There's just one area that will come from your knowledge. Okay, let's go ahead and get started. Number 1 is what, Chris? It is condensation. Good. Number 2, Devin. Precipitation. Very good. Number 3, Jenny. No. Almost. Madison. Infiltration. That's the breaking in. Notice the ground, it looks broken. That's the breaking in of water. You see the rain on that ground, it's breaking in. Number 4, Ray. Transpiration. Very good. Number 5, Devin. Evaporation. What? No, it's actually coming from the surface water. Number 6. Nobody knows what number 6 is? Aaron? Groundwater. No? Raise your hand, please. Simon? It's already labeled surface water, so no? Absolutely not. Well, kind of, but we call it something else. Runoff. Number, 8? Nope, 7. 7 is, Jenny? Percolation. Very good. It's that movement underground. Number 8 is the one that you do not have vocabulary for, but in one of our slides, it showed you that zone right above the aquifer. That zone was what, Duran? Close. Zone of aeration. That's your aeration zone. A-E-R-A-T-I-O-N. A-E-R-A-T-I-O-N. So aeration zone. Number 9. That top layer. Eddie. Water table. Aeration. Aeration zone. It has the word zone already there. And number 10, I should have said also that one is not part of your vocabulary. It was called something else. Who remembers what the groundwater zone is called? Jamil. Saturation. Saturation. That's your zone of saturation. Any questions? That was 1 through 10, right? Any questions on that? So how are you going to study? You're going to fold it, and you're going to fix it that way. I'm going to move on because we still have time. So here you go, your answers in case you did not get them. This right here can say unsaturated or aeration. I like for you to put aeration instead of unsaturated. Yes. Just another layer underground. Aeration. All right, let's keep it moving. If you flip your paper over, you have groundwater notes. Now what I'm going to do, I'm going to play a short video. While I'm playing the video, you are to try to fill out as many blanks as you can down here based on your prior knowledge Duran, sit down. If you're moving up there to see, you do not play with someone on the way. All right. While you're watching the short video, you are going to be filling out as many blanks as you can on the part that says groundwater notes. Okay? You need to have a little bit of background knowledge, but it's going to actually give you some information about that. It's actually going to move through quite a few of these. Some of these things you have to use your brain, and some will be on there. It may or may not go in order, but that is part of your note building, note process. Please do not get frustrated if you don't feel like you got everything. Try to get as much as you can. The purpose of this is to help you with your note-taking strategies. You have to develop an ability to do two things at once. In this case would be listening, well, three things: listening, watching, and figure it out in writing. Take just a moment and read through your notes to see what it is that you are looking for, so that when you hear it, you know, oh, I did see that on my paper, that goes here. These are also notes. So let's say you don't find the area that you have to put it in, but you do feel that that is important. Jot it off to the side or on the bottom somewhere. So that way when we come to it, you'll say, oh, I did put that, that goes here. Do you understand? Okay, so just take a minute just to review what the paper says and what it's asking for. No talking over there. Do that by yourself, and then I'll play the video. About 20 more seconds. Okay, here we go.
We all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water: groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer. There are huge aquifers all across America. The biggest is the High Plains Aquifer, which covers 174,000 square miles right in the middle of the country. Anything that big deserves a closer look. Let's say you could grab a shovel and dig straight down through the soils to an aquifer. The level underground where you first hit groundwater is called the water table. Below the water table, the ground is completely soaked or saturated with water, which is why this area is called the saturated zone. The area above the water table is called the unsaturated zone. So, how does all this water end up in the ground? Well, it's all a part of the good old water cycle. When it rains, some water gets soaked up by plants. Some water runs off the soil and into streams, lakes, or even the ocean. Other water gets stuck on the surface and eventually evaporates back into the air. Meanwhile, some of the lucky water droplets get to travel down through the surface deep underground until they reach the water table and become a part of an aquifer. Once water seeps down deep enough into the ground, it can stay there for a really long time. Some of the water stored in the deepest parts of aquifers has been there for thousands of years. But after it gets there, groundwater doesn't always stay in the ground. A lot of the water on the surface comes from aquifers. If the surface of the ground dips below the water table, groundwater flows out to space, creating a body of surface water. If the surface water dries up, groundwater can flow in to fill it back up. And if the water table in this area rises, so does the level of the surface water. Groundwater can also pour down a sloping surface, creating streams. Any place where groundwater flows out into the surface is called a spring. Surface water can also become groundwater. If a body of surface water flows above the water table, water can seep down through the sediment and help fill the aquifer. Of course, there's another way that groundwater can leave the ground. Us. Humans depend on groundwater, and there are thousands of wells all over the country that draw water out of aquifers. In many parts of the country, the water you get from the tap comes from the ground. However, we use most of our groundwater to help grow the food we eat. Farms can get lots of the water they need from rain, but rain isn't always enough. And in dry years, farmers depend even more on the water that's stored in the ground. In fact, American farms use about 53 billion gallons of groundwater every day. That's enough to fill over 1 million bathtubs or 80,000 Olympic-sized swimming pools. So, if we're using that much every day, can it run out? Well, yes and no. Remember, aquifers can be refilled by rainwater or surface water seeping in from rivers and streams, so there's usually more water on its way to replenish the aquifer. But if we use groundwater faster than the aquifers can refill, we could drain them dry. They probably wouldn't be empty forever, but it would take hundreds of years for the largest aquifers to get back to healthy levels. Whether it's up here or down there, water and how we use it matters. We may not be able to see it every day, but groundwater makes our lives possible. So don't let show-offs like rushing rivers and roaring oceans get all the attention. Those unseen aquifers below ground have been here longer than we have, and with a little love and care, they'll keep on taking care of us long into the future.